Good morning, children. Welcome to our online revision class of physics. Okay, children, you all know we have FA1 exam on 23rd onwards. So it consists of 20 marks, 1 mark questions 10, 2.5 marks questions 2, and 5 multiple choice questions. Okay, now total you are going to write off 20 marks question paper. Okay, children, now we will revise what we have learned in the last classes. Children, see here. Generally, we all know that there are three states of matter. Okay, now we will see examples for those three states and characteristics: solid, liquid, gas. These are the three states of matter we have. Example for solids is your computer. Okay, best example: table, chair, everything is a solid. See here, the particles in the matter is closely packed. They are in a fixed position. Okay, now they are rigid and cannot be squashed or compressed. So solids have fixed shape and fixed volume. They cannot flow as like liquids or gases. Now take the example of liquids. Liquids, okay, the gas molecules in the liquids are not closely packed as like solids. They are closely packed but not as much as like solids. Okay, now liquids take the shape of the container. They don't have a fixed shape. They are not rigid. Okay, they are not rigid and they cannot be squeezed or squashed as like compressed as like gases. Okay, they are also cannot be they are not compressed as like solids. Now liquids doesn't have fixed shape. Okay, they have fixed volume only. Now take the example of liquids in a glass of water or a cool drink. Okay, they take the shape of the container. Will they flow? Yes. Now take the gases. So best example of gas is helium, that is air gas in the balloon. Why? Because helium has less dense than air. Okay, now gas molecule, so particles in the gases, they are placed far away to each other. They are not placed as like of solids and liquids. Okay, now can we compress the gases? Yes, we can compress the gases, and gases do not have fixed shape and fixed volume. Okay, now see here, children, solid, liquid, gas we are comparing. Okay, and there is a fourth state of matter, that is plasma. Okay, okay, children, till now we have seen the different states of matter, but now we will see what is matter. Okay, what is actually the matter is. So matter is nothing but having certain mass and occupies some space is nothing but matter. Okay, what is matter actually? The substance which is having certain mass and occupies some space is nothing but matter. Okay, now the three states of matter is solid, liquid, and gases. Solids. So see, now we will see the example of a solid type of matter. See, here is a rock. Okay, a small rock it is there. Now it is the best example of a solid. Is it having definite shape or not? Yes, every rock is having certain shape. Okay, some shape it will be there, and otherwise we can bring into a definite shape. Now take the example of a liquid. So here I am taking a glass tumbler in this shape. Okay, now 50 ml water I am pouring in it. Now what is the shape of the liquid? It is like this. Now if I take a glass tumbler in a rectangular shape, okay, in a rectangular shape, if I take the same 50 ml water, okay, how the shape of the liquid now? It is in the shape of rectangle only. Am I right or not? That is why liquids doesn't have a definite shape. They takes the shape of the container. Now okay, now see here, children. Okay, see, children, here I am taking a container. It is in this shape like this. So in this container I am pouring a liquid. Now what is the shape of this liquid? It takes the shape of the container. In the same container, if I put a rock, what is happening? The shape is changing? No. That means rock is rock's shape, that is solid shape, is a fixed shape, whereas the liquid takes the shape of the container. Now here is a cup, and in another cup, okay, there is a liquid. I am pouring the same liquid from one cup to another cup. That means liquids can flow. At the same time, the gases can flow. Okay, the gases too can flow. So children, there are some liquids. Okay, there are some liquids which cannot flow as like as water. Now see here, both liquid and gases together called as fluids. Okay, both liquids and gases togetherly called as fluids. Remember this point, very very important. Okay, children, see here, now we will talk about density. What is density actually? Mass by volume. Okay, mass by volume. Now take the example of a iron. Okay, in the solid form, what is its density? 7870 kg per meter cube. Okay, mass by volume. Now take the same iron in the liquid form. Okay, when you heat the iron at high temperatures, it is in the liquid state only. So at that time its density is being 6980 kg per meter cube. Okay, no need to worry about the values of density. Only you have to observe that density of solid is greater than the density of liquids. Okay, that's the point you need to remember, that is density of solids is greater than density of liquids. Similarly, take the example of a water when it is in liquid state and when it is in solid state. Okay, see here, when the water is in liquid state, its density is 1000 kg per meter cube. The same water, when it is in solid state, it's decreased. It is in solid state, that is when it is in the form of ice, its density is being decreased. Okay, now see children, so on the whole children, solids are having high density than liquids and gases. See here, density of air is some 1.2 kg per meter cube. Okay, take the example of a density of water. What is the density of water? 1000 kg per meter cube. That means liquids are having high density compared to gases, but finally on the whole solids are having high density than liquids and gases, and liquids density is greater than the gases density. Okay, now which is having least density? Gases are having least density. Okay, now children, take the example of solids. Don't confuse, here there is a point, solids, liquids, gases. Observe the third point clearly so that it will be clear to you. Now let's take the example of compressibility property. See, in solids, each and every atom or particle is closely packed. That means we cannot compress it. What about liquids? They are placed slightly far to each other. Okay, so that there is a space between the particles in the liquid, particles of the liquid. What about gases? They are much far compared to liquids. Okay, now we will see phase changing, that is changing of matter from one state to another. We all know there are three states now. So how solids will change into liquids, how liquids will change into gases. What is that reason behind change of state of matter? We will see now all these things. See, take the example of solid children. Here there is an ice cube. Okay, now heat the ice cube. What happens when you heat the ice cube? It will melt and becomes water. Okay, that means here ice is absorbing heat and changing into liquid. That is, solid state is changed into liquid state. Now again, if you give the heat to the same liquid, that is water, what happens? It turns into gases, that is, it vaporizes. Okay, it becomes a steam. The example is, take the bowl of water and start boiling it. You can observe vapors at the after certain time. Okay, here in solids, what happening? In solid, the particles is very close to each other. In liquids, they are having some space, and at the same time in gas they are placed far to each other so that it can diffuse into air easily. Which are placed far to each other, that is particles. Every atom matter is made up of millions and millions of tiny particles. What are those particles? Nothing but atoms. Okay, now see. Okay, hope you all understood now, children, how the phase is changing from solid to gas by absorbing heat. So here, if you observe clearly, in every state we are giving heat change. So solid to liquid, liquid to gas. Now see, whenever a matter is changed from solid to liquid, it is melting. Okay, we call it as melting. Similarly, whenever liquid is changing into gas, we call it as vaporization. Okay, whenever the solid state of matter is changing directly into the gas, we call it as sublimation. Okay, now for example of solid to liquid is CO2, solid CO2. Okay, solid carbon dioxide. Okay, whenever we heat it, it directly changes into gases. So if you observe, all this process are changing of state of matter, that is melting, vaporization, sublimation. In all these situations, matter is absorbing heat, whether it is changing from solid to liquid or liquid to gas, solid to gas, whatever it might be. Every time it is absorbing heat, so that we call it as an endothermic process. Similarly, whenever the liquid is changing into solid, that is freezing. Gas to liquid means it is condensation. Gas to solid. Okay, in all this process, we call it as exothermic. That means we are taking out the heat from it. Okay, now it is very, very important to learn all these definitions: melting, vaporization, sublimation, freezing, condensation, deposition. Okay, which is exothermic, which is endothermic. All these you need to learn clearly. Okay, hope you all understood the changing states of matter. Okay, you need to learn clearly. I gave you the classwork notes also, so study all those things clearly. Okay, children, now we will see about rest, motion, and all these things. Okay, see here, a boy is sitting under the tree. With reference to tree, he is not at all changing his position. So at every time his position is same. That is why we say this boy is in rest. Okay, now, so movement in a straight line is called rectilinear motion. Movement in a circular path about a fixed central point is called circular motion. Okay, movement that repeats itself at regular time intervals is called periodic motion. Movement resulting due to the combination of linear and circular motion is called rolling motion. Okay, remember these points. Okay, now see, children, motion in a straight line. So in this we will see distance, position, displacement, average speed, average velocity, instantaneous speed, instantaneous velocity, all these things. So all these things we have studied previously in my classes. Nothing is new to you, so it is just a revision for you, quick revision. Okay, that is why we are saying all these things. Nothing is new to you. Okay, you all know what every point in this. Okay, now see here, children, the study of describing motion is nothing but kinematics, and the study of the causes of motion, causes for the motion of a body, is nothing but dynamics. We call it as dynamics. Okay, now Now we will see the points are terms related to the motion chapter, that is distance, displacement, everything. Okay now first we will see distance before going to study. See here children, see here. Now in motion, in straight line motion, we will see distance, displacement, all these terms. See here I took a number line. So number line in the sense, here I am indicating some distances, 10 meter, 20 meter, 30 meter, and at the same time negative side also, that is minus 10 meter, 20 meter, like this. Now see, with red sketch I am showing a body started at 10 meters and reached to 30 meter, and again it's traveled in that opposite direction and stopped at 0 meter. Now tell me a body which is started at 10 meter and reached to 30 and again it came back to 0 meters. What is the total distance it traveled? So what is the total distance it traveled? So now take the example of that the total time it took is 10 seconds to reach from 10 meters to 0 meter. So total distance it traveled, the duration is 10 seconds. Now what is the distance? Distance is nothing but the total path traversed by a moving object, isn't it? 10. So 0, 10, 20, 30 meters. What is the total distance? 50 meters. Okay. Total distance is 50 meters from 0 to 10, 10 to 20, 20 to 30. Okay. All these is 50 meters. Now in position, that is, what is position? That nothing but the location in its journey. Displacement can be both negative and positive. So it is a vector quantity in the sense it's a minus sign indicates it's a direction only, back side. Okay. So here minus 10 meters is the displacement which we got with this example. Okay now we will see average speed. Okay, average velocity, remaining terms. Okay now children, I hope you understood. Now see here, average speed. Average speed is the total distance traveled by time taken to travel. Okay, that is total distance by total time. It gives you average speed. Here speed is a scalar quantity. Why? Because distance is a scalar quantity, and so speed related to distance will give you a scalar quantity only. Here we will study only a magnitude, no need of direction. Suppose see here, what is the speed distance we got in previous example? 50 meters. And what is the time we took? 10 seconds. Now what will be the average speed? Total distance by total time gives you 5 meter per second. Okay now take the example of velocity, average velocity. So average velocity gives you displacement by time. What is the displacement we got in this case? In the previous example, minus 10 meter. So take with the sign itself, minus 10 meter by time 10 seconds. Okay, see what do we get? 1 minus 1 meter per second. This is the average velocity. Okay now, so from 10 meter to 0 meter, the displacement is minus 10. And what is the time it took? Minus. Okay now, in the negative direction it is moving. Okay, that is why it indicates negative sign. Okay now, 10 to 0 in the backward direction, that is why the direction indicated is minus 1. That it is left side, we are moving to the left side. So that tells about in which direction we are moving, that is left side. How we are telling? Based on the sign, that is minus sign. Okay, if we take north, south, west, east, west direction, like that directions, then we can say 1 meter towards west, or 1 meter towards 1 meter per second velocity with towards east, like that we will say. Here a number line we took, what we took is number line, so that is why we got minus sign. Okay now children, now we will study instantaneous speed, that is the speed at some 5 seconds, or the speed at some 6 seconds, or the speed at certain time. So the time, so if you want the speed at a particular time, so that speed it will tell you about instantaneous speed. So speed at that particular instant time will gives you instantaneous speed. So example is when you are sitting in a bike, or when you are riding bike, if you look at bike at a particular speed time, what happens? You observe some 60 km per hour. So then immediately you can say that instantaneous speed is some 60. Okay, that is nothing but speed at a particular instant of time will give you instantaneous speed. Okay now, so instantaneous speed, yes, is equal to, okay, very, okay, so very small distance, nothing but, so I already told you the speed at a particular instant of time is called instantaneous speed. So very small distance by very small time will give you instantaneous speed. Okay, so the best example is when you are riding a bike. Okay, so when you observed the speedometer, what happened? You saw that bike is moving with some 40 km per hour. So 40 km per hour, with that speed it is moving. That means the particular, so at that particular instant you have seen the speed is some 40 km. That will be your instantaneous speed. So there you are not worrying about how much distance I traveled or how much time it took. There you are not worrying. That is why I wrote very small distance by very small time. Okay, the meaning why I wrote, you understood, I think. Now take the example of, now one more term, that is instantaneous velocity. So velocity is also same here, something limited, delta x by delta t, all these things. So no need of going that much limit all these things. Velocity is also same, the displacement by small, or the small displacement by small time interval. Okay, velocity is also same. Difference between speed and velocity is only one thing, that is speed has only magnitude, velocity is having both magnitude and direction. Okay na children, so instantaneous velocity is nothing but del, so dx by dt, that is velocity in displacement by time. Okay, now we have seen, see here we have seen distance, position, displacement, average speed, average velocity, instantaneous speed, instantaneous velocity, all these things we have seen. Remaining term is average acceleration. Now we will see average acceleration. So acceleration is nothing but change in velocity with respect to time. Okay, so a car moving, see here when a car is moving, average What is acceleration? Change in velocity by change in time will give you acceleration, average acceleration, change in the velocity. What is the unit of acceleration? Meter per second square. Okay na, velocity is nothing but meter. Okay, what is the unit of velocity? Meter per second. And what is the unit of time? Second. So on the whole we will get meter per second square. This is the unit of acceleration, that is meter per second square is the unit of acceleration. So here take an example. A car with a constant acceleration of 4 meter per second square will change its velocity by 4 meter per second with every passing second. Okay, see here, a constant acceleration, that is 4 meter per second square is given, and okay, acceleration is given here. Now see in the diagrams, will change its velocity by 4 meters per second with every passing second. Okay, that is change in the velocities, every time it changes its velocity by 4. Okay, and for each second, okay, for each second it changes its velocity by 4. In the first see here, in the 0 seconds its velocity is 0 meter per second square, initially at rest. Now at 1 second, after reaching to 1 second, its velocity is changed to 4 meter per second. Now after reaching second, okay, initially 0 1, now it came to 2 seconds. After completion of 2 seconds, again its velocity changed to another 4 meters. I am telling another 4, that means already at t equal to 1 second there is 4 meter. Now it came to another 4, you have to add, so 8 meter. Like this it is changing up to t equal 3 meter. Okay, 4 meters, 4th second, its acceleration is being changed by 4 every time. Okay na? So hope you understood how the velocity is being changed. That is, change in velocity gives you acceleration. Acceleration is nothing but change in the velocity. The important point you need to observe is acceleration is equal to change in velocity by change in time. Okay na? This thing you need to observe. Okay children, so like this we will study everything. Okay na? So take care and study thoroughly your classwork notes, everything. Okay, thank you.